Hey, good afternoon, everybody, and good morning, or maybe good evening where you are today. Welcome to Cassandra Lunch 48. Wow, it's almost a year. It's probably we've been doing it for years, just we haven't done every single week. But today's topic is Airflow and Cassandra, both Apache projects that are very popular, especially Airflow these days, and we'll be presenting on it. Obi's done a few presentations on data operations tools like Airflow, Luigi using Jenkins for Airflow. So I'm excited about his thoughts on how we can leverage it for Cassandra. I'm your organizer for this meetup. We are always looking for co-organizers and speakers. We're part of a larger community called Data Community DC. Data Community DC is made up of many, many, many meetups around data, as you can imagine. We cover here all things related to the Cassandra protocol, which means, for example, the CQL, or in some cases, the clones like ScyllaDB even have similar gossip protocols that talk to each other. So Cassandra and DataStax are just one type of Cassandra now. Anybody new? I don't see any new people particularly today. Let's go ahead and continue. Group roles, if you have a question, just ask. Our company Anant helps people build platforms that run the world. We basically global data analytics platforms that help run global business platforms. And we focus on Cassandra, Spark, and Kafka because it's pretty much the only open technologies that allow people to do that. DataStax is a partner. So is George Washington University. We have a few local sponsors as well as some organizational sponsors for Data Community DC. Let's see. Don't imagine there's any announcements for anybody in the audience right now. However, we are hiring data platform operator, engineers, and architects. You can go check out our site, careers.anant.us. Also, we have Cassandra events every week here. So Cassandra Lunch is every Wednesday at noon. Data Engineers Lunch is every Monday at noon, same general format. And we have a few exciting topics coming up next week. Spark SQL for data operations and machine learning with Spark and Cassandra. You can always check out previously broadcast meetups at Cassandra Lunch on YouTube. Just look for, or you can look for Cassandra Lunch on Google. And then we have our Cassandra.Link, which is the world's best knowledge base on Apache Cassandra. And we hand curate content. We aggregate from the experts in the Cassandra community. And with that, I will pass it to Obi.
All right. Hello. Give me a little bit to get set up properly. Today's presentation is on Airflow and Cassandra. Specifically, what we're going to be talking about today is the Cassandra operators and sort of the way that Airflow interacts with Cassandra through the Cassandra driver. There's potentially another presentation on this topic for some time later on about how Airflow can interact with Cassandra as a system, sort of running no tool commands and things like that, and maybe doing stuff like trigger compaction or read repairs. But to start off, we're mostly going to be talking Airflow, because this is Cassandra Lunch. I assume people have some sort of understanding of Cassandra. So the overview of Airflow is it is a workflow scheduling and automation platform. It's good for automating repeated processes like common ETL tasks, machine learning model training. It's good. You write your workflows in Python. So any tools that are interactable via Python work pretty well, as well as they have operators for some other stuff that does not work via Python, in case you wanted to put in like bash commands and things like that. Um, you can schedule your workflows or execute your processes by hand using the command line interface or the UI, and it monitors your tasks and collects logs and allows you to view them when you run them. So Airflow has a bunch of features. You can see it creates DAGs in Python. It has its own UI. And in fact, Airflow 2.0 is a distributed system. Um, so you can run it across a number of machines. The main component of Airflow's operation is DAGs. You build them in Python. Stands for Directed Acyclic Graph. Um, it is a graph of tasks with dependencies as edges. Um, so individual data engineering tasks, which you build in Python, combine together to perform a DAG, which fulfills some greater task. Um, Airflow allows the definition of relationships between your tasks. Inside that same code, you define your dependencies and your run order. Um, so you can also assign them a priority so that things with the same, like within the same, with the same dependencies, decide in which order those run. And DAGs are run on a specific schedule, which you can set. Over on the right, you can see there's some sort of like cron notation for defining that schedule, and you can also trigger them manually using the UI or using the APIs. Okay, so now we get into sort of the meat of the presentation today. Airflow providers. Airflow has a whole bunch of provider packages, as you can see over on the right. They are community maintained, and they're for integration with any external systems. So you can see Amazon inside that. There's like stuff for connecting with S3 and any other AWS systems that you might be using. There is, of course, Apache Cassandra, as well as a whole bunch of other things, including stuff like Elasticsearch and Spark. And it is possible to create your own provider packages. But if you're using one of these, one of the listed ones, it's best to just use their provider package. So another component of how Airflow connects to external systems, Airflow manages your connections for you. You can see that in the UI, or you can interact with it via command line. And it manages your like network connections with your external systems. So your authentication, username, password, and any sort of special variables for connecting to this specific type of system. Like for example, the Cassandra one has username and password, host name, etc., port, but it also has key space name and stuff like that. If you want to define, it would be the same as using a use key space name command in SQL shell. It will interpret all of your queries in the context of that key space in the future if you define that variable. And so Airflow manages them, but underneath it's essentially just a JSON string, which when you are running your DAG, Python turns into a dictionary so it can get the information out that you need. Okay, so operators. Airflow operators are individual tasks essentially. So they're a certain type of task. Different types of operators contain a bunch of different functionality. And the provider packages often come with some of their own custom operators. We'll talk about what are in the Cassandra provider package later on. But the main Airflow operators are Python operator, bash operator, and branch operator. And with those three, you could define a huge number of DAGs just by having your Python code, your shell scripts, and your logic via branch operator. But the Cassandra provider package comes with two operators, their sensors, Cassandra table sensor and Cassandra record sensor. What they're supposed to do essentially is to poke at the Cassandra table with some frequency until it detects the table or record within the table that you give it. And the way that that sort of works is that it's built on top of what's called the Cassandra hook. You can go look at the code for it there if you want. But the Cassandra hook class manages the connection between Airflow and Cassandra. It's doing it using the Python Cassandra driver. So you can do things like check a cluster for a table or check a table for a specific record, but it also exposes a session object to allow for your own arbitrary queries. Anything that can go through the Python Cassandra driver can go through the Cassandra hook. And you can combine it with Python operator to execute those. So essentially you create a Python callable, either a class or a function definition, and then give it to the Python operator and it will run that for you. Okay, so going on to the demo now. Give me a second to switch how I'm sharing my screen because of this computer that I'm on. Okay, so on this machine, there is already a it's a DSE cluster up in Docker. The Airflow instance is actually running on the machine. It's not in Docker containers. And this is the DAG that I've written for this example. It's Cassandra Hooks DAG because I was unable to get the example Cassandra DAG that uses the operators to run properly, but using the hook directly with the Python operator worked fine. So inside of an Airflow DAG, the first thing you do is you define your arguments. Some of these are necessary, like owner, but the others are all pretty much optional. And in fact, you can see a large number of these here are commented out because we don't actually need them for this. So in our Python, before we go into either any of the function definitions or into the DAG description, what we're doing is we're starting up the Cassandra hook, giving it a connection name. The connection in this case is Cassandra default, which if we go look at the Airflow UI, we can actually see that Cassandra default.
Could you zoom out a
Very
little
simple.
bit, Obi?
Not really. For some reason, I can only share a portion of screen, and I can't control how big that portion is, really.
Is this because you're on Linux, or can you just share
Yeah,
your whole screen?
I'm on Linux. It's only allowing me to share a portion of the screen.
What if you share the whole window?
Well, I can go back and share Chrome again, and
Yeah,
that would.
Yeah, I think that's because that's how you were able to present earlier. I think that's just,
Yes.
Yeah,
That works. So inside the Airflow UI, you can see that the Cassandra default didn't really have to fill any of this in. They had host listed as Cassandra, and I changed it to localhost because of the way I'm using Docker. The port 9042 is exposed on the host computer, so I can just connect to it here. And other than that, I didn't have to have anything here because key space, name, and all of this other stuff, you don't need a username and password here because there's no authentication set up on the cluster. So we can just go into it. We can actually, I remembered, look at the code inside this window. So you won't be able to see me run it. Well, I could potentially run it here, but you wouldn't be able to see any of the results. We'd have to go look at the logs to see anything that happened. So we're probably going to need to switch back to the other view in order to actually run it. But the code is all here just fine. So after we create our Cassandra hook with that connection, we're defining some Python callables, in this case functions, one that replicates that sort of Cassandra check table sensor that is in one of the operators that I couldn't get to work. All it does is you give it a key space and a table name, and it sets that key space and then checks if that table exists. And then another one that just executes a query given as a string. So you give it the string the same way you would the Python Cassandra driver, and it essentially gets that session object from the hook and gives it the query and then executes. And then we're defining our DAG. You can see both of them are using Python operators with that specific function as the Python callable that it's being passed, as well as arguments, which of course it is possible to define dynamically. If you have, say, global objects in your DAG that change based on previous steps, you can then use them to define the inputs arguments for future steps. And then down at the bottom, we just set one single dependency where if table check fails, you don't go on to select all.
Effectively, we don't know why the Cassandra table sensor and the Cassandra select or record sensor didn't work, but you just made your own essentially just by using the Python.
Yeah, I was having trouble getting them to work properly. So I just wrote one, and it's 2 or 3 lines of code, so it's not difficult.
Yeah. So question that I've been thinking about is, so these DAGs, I saw that you put at the very top certain options. I know that certain options we set inside the GUI. So are these standard for all Airflow DAGs, or can we set custom properties for arguments and then have those show up as UI elements on the user interface?
Well, I think these specific ones are for all Airflow DAGs. I don't know if you can add arguments and have that change what shows up on the UI.
Okay, got it. I mean, there must be some mechanism via metadata to expose UI because otherwise, how would they have done the connection UI for Cassandra? Right?
Yeah, and well, a lot of the UI elements also have a sort of what am I trying to say? They have an underlying API that you can just interact with. So it's possible that there's some change you can make in there that will define what default arguments are available there. So now we're just going to test it. So rather than having it run via the UI, we're using the Airflow DAGs test in order to run just a single instance that shows up local executor, so we can get all of the output here on the terminal instead of going and having to dig into the logs to see that.
I mean, when you're testing it, it's not like it's running through your cron schedule, right? Like it runs it right then and there, right?
Yes.
It's like a force trigger. Yeah. Okay.
Yeah. I mean, in the UI, there is a trigger DAG button, so presumably, like it's possible to do that the same way where you just manually trigger, but you can also set your schedule using this same sort of interface. All right, so it's running. Whoops. Basically right now, everything's just printing out. But you should be able to see once we get past this huge block of everything that was in that table, because that's the request I sent. You can see up at the top, there is the section where it's running the first task, marking task as success, Cassandra hooks tutorial table check, which you can see here, where it went in and checked if the table existed. And since that's successful, it goes to the next one, which runs the CQL query, select star from test.users, which is where all these 1,000 rows of data are. And it's just printing it out at the moment. But like I said, it's possible to do any sort of data operations that are available using the Python Cassandra driver. So it doesn't include things like describe key spaces or describe tables, since that's specific SQL shell functionality, but you can do things like alter tables, select data, insert data, all of that stuff.
It's great. Yeah, I was thinking, you know, like, not to get into the client specifics, but you know, the cleanup tooling that, you know, we've been working on, technically, if we wanted to have a schedule, we could have like a schedule table in Cassandra that has, well, not really the schedule table, the metadata would be there potentially, right? So we could have a schedule in Airflow, but the metadata would be in Cassandra, and an operator could get that information and pass it off to a Spark job, right, to go ahead and execute that cleanup. The other thought I had was, that's what I was asking about the user interface. Like, is there an opportunity to expose metadata inputs, you know, in the UI? Because basically this is an amazing way to automate everything, but the first input is always the, you know, what do I want to do? And from an operations perspective, like it'd be nice to say, okay, run this operation on this key space, which could be blah 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 blah, right? And it's bash would execute XYZ, or like you mentioned, repair or compaction or whatever, right, on a particular thing, instead of having to like go to the code and say, here, do it on this table, you know. Yeah, that's pretty cool. Yeah, there's so many different things on Cassandra without even considering all of the Spark stuff, where actually there's a lot of metadata in Cassandra about Cassandra in like the system key space. And the Cassandra 4.0 has something called virtual tables, and the virtual tables have the same information that is available in Node Tool. So when we do Node Tool table stats, when we do Node Tool status, and a lot, that data is available live in that particular table on that particular machine. And I think that when we consider what could be done, just querying those tables, it could be like, you know, do this query if the load is over, you know, 80%, you know, do XYZ, for example, you know. So yeah, that's interesting. Anybody else have ideas or questions about how Airflow could be used for, you know, just working with Cassandra? I mean, there's a billion things Airflow can do, but specifically with Cassandra. Okay. Well,
so I just wanted to, for my own understanding, Airflow is not so much for actually altering the data itself, but scheduling other programs to then alter data or do the ETL type transactions.
Yeah. So even like having having your actual Airflow like scheduler, the sort of like brain of Airflow, do a whole bunch of processing is not really what you want, even if you're not working with external systems. So the Python operator actually brings up a worker. So it's not running that code on the scheduler, which is responsible for the scheduling. It's bringing up a worker to do that work and then closing it down when it's done. And that's even before Airflow 2.0. So the purpose of Airflow is sort of to schedule this and then send out the work either to a worker or to an external system like Cassandra or Spark to be done.
Yeah, from my understanding, it's used for data pipeline management, but technically it's just a task manager that waits for things to be done to then sequence the next one and to sequence the next one. Like ultimately it's like a glorified cron job manager, which checks dependencies before it tells the next thing to go forward. But it's more than that. I mean, obviously the user interface is what kills it. It's great to write one, like what you showed was a simple DAG, a very, very simple DAG. But the power of putting that into Airflow is you can say, schedule this every day or schedule it every hour. And it will measure how long it takes. It'll measure if it failed, how many times it failed in a particular day. We could have a login interface in there. So, people, not everybody has access to this. Somebody could come and trigger it. So this technology, I mean, if you're relatively new to the data world, like people used to spend in large companies millions of dollars to license scheduling software, just not even with a GUI, not even with like a nice interface like Airflow. And so when something like this, or like even Jenkins, for example, we used to spend thousands of dollars to be able to use something like Jenkins. Now Jenkins is open source. And pretty much all of the commercial vendors, the only reason they're surviving is because, well, they have some sort of managed version of it on the cloud. But specifically, like the scheduling problem, the data scheduling problem, almost every single customer I've ended up working with that has serious data stuff, they start with cron jobs, and then they end up having to use something like Jenkins to run the job every now and then. And then they see Airflow, they're like, whoa, we should just use Airflow now, because it's like, it's so much better than anything else out there. So very cool. Good presentation, Obi. Any other question about this or anything related to Cassandra? Okay. All right. Well, if there are no other questions, then we can call it a day and give you guys back 30 minutes. Awesome. Thanks again, Obi. Appreciate your presentation. Good work.
Yep.
Yeah, thanks, Obi.
All right, take care, everybody. See you all next time, next week, same time, same place. Bye-bye.
Great presentation, Obi.